for the first time. Right.
Good evening, all.
Good evening. Good evening.
Welcome to the Welcome to this online program, Demystifying Quantum Computing for the school students and beyond. I can see eminent professors, Iapt officials, including National President Dr. Alwale sir,
Namrata Baile.
BP Tyagi sir, Vandana ma'am, all eminent Iapt officials and many students joined this program. If I give the statistics, there were 113 registrations, among which 37 are from teachers and 76 are from students. So thanks. Thank you all for this overwhelming response. And I also welcome today's guest, Karthi Ganesh Garu. Welcome, sir.
Yeah.
Yes, sir. As this inaugural session is very tight, and since I was given only 1 or 2 minutes to, and hope this program will give you so many inputs and throw some light regarding some topics in quantum mechanics. I hope the course coordinators and all the instructors will give a lot of inputs on the emerging topic quantum computing. With these few words, I'm signing off and wishing all the participants to make this a grand success, and hope you enjoy the sessions day by day. Thank you for giving the opportunity.
Thank you, Dr. Madhusudan, for your kind words of welcome. Once again, let me request all the participants, each one of you, kindly mute yourself and unmute only when you're about to speak. Okay, thank you. So to proceed with, may I now request the convener of this summer school on quantum computing, Dr. Arvind Kulkarni, to give us a brief introduction of this program. Kulkarni sir, are you there? Oh my God. I think sir has lost the range. Kulkarni sir.
Rashma ma'am, meanwhile ask
I'll proceed.
Professor Rajeshwara to speak, ma'am.
I'll proceed. I will give time to Kulkarni sir once he joins. So to continue, may I now invite Dr. P.K. Walia, President, National IAPT, and also the patron for this workshop, to kindly deliver his address. Aluwalia, sir.
Thank you. Thank you very much, Dr. Rishma. Dear participants.
Yeah.
Professor Arvind Kulkarni ji, please you speak.
Yeah.
You speak. I'll speak later.
Okay.
Yeah. 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 Can I go ahead? Sorry,
Yes,
there was some problem at my end. I will be doing the introduction part. I beg pardon for everybody. I am Dr. Arvind Kulkarni and the convener. Now, regarding quantum computation, what, how, and why, I think enough will be said down the point. So I do not waste my time, but we wanted to say one thing. At IAPT, we thought that it is important to bring the Indian academic community, the students and teachers, on par with the latest development in the world and then quantum computation was a very important issue, we thought. So why quantum computation and why we should do that? Lot of things will happen here, and how we want to do it. We wanted to give a flavor to what exactly quantum computation is to the students and teachers in this country, so that they will take over. We are not claiming that we want to educate the whole India. No, not at all. We just want to make a small beginning so that others will pick up from here and proceed forward. We want to see not less than 8 to 10,000 students and teachers across the country covered within the next 3 to 4 months during the summer vacation. Notice that in India, summer vacation is split into two parts. It's April, May in southern part of India, and then June, July in the northern part. So we thought about this 4 month program, or what is called as a summer school in quantum computation. This is the thing. Now, here we have people to be introduced. You will be finding Dr. Ahluwalia, IAPT President. Then we'll have Vandana Luthra, the course coordinator, and also the computer teacher from Delhi. Then you have Rajiv from Delhi. Then Jyoti Ghuche from Pune. She is the first speaker today. Then you have Abha Khandelwal from Dr. Abha Khandelwal from Nagpur. She happens to be the niece of the originator of this IAPT in 1984. Then you have other people like Rajiv Tyagi from New Delhi, Kiran N from Mandya, and Dr. R. Balakrishnan. These are the six or seven people I have only named. As the program unfolds over the next several days, whenever the speakers come, will reintroduce them in a systematic way. I would like to announce that there are 113 paid participants, of which about 20% are school students, about 10%, about 25% college students, about 25% postgraduate students, and about 25 to 30% teachers. So that is the distribution. Total number is 113 and about 15 to 20 guests. Average age of the teachers is approximately 40, 42 years, and average teaching years, each of these six teachers I put in is minimum 20. Average, this is not the minimum, this is the average 20. So I just wanted to give a feeling that we know what teaching is and then how teaching needs to be done. So we have taken up people who are sufficiently educated and experienced uh, in their work. Second thing I want to introduce is the volunteers team. The volunteers team consists of Dr. Reshma Rao Desai from Goa and her team of volunteers, whom I'll be naming here. The team consists of Mayuresh Aya, who has done an MSc Physics, and Miss Prajakta Lotlikar, MSc Physics, 3 years experience, Miss Mruga Rabolkar of MSc Physics, 5 years experience, and finally Shubhankar Bandekar, MSc Physics, presently pursuing PhD. So we have a very young team of volunteers led by Professor Reshma Rao Desai, who is also the compere of this program. Okay, then I wanted to talk about one more thing, namely uh, our people who are our observers. There is an observers group, which means that people, the whole exercise over the next 10 days will be observed by these very senior, sensitive people who will give us inputs on what is happening. They may not be talking during the sessions anytime, unless they wish to sometime towards the end, we will invite them, but otherwise you are being watched. I want you to see that
என்னது
it's already on camera, but there is another
தியான்
camera.
வந்துச்சு அவன் தான் அவனை
So
தேடி தர சொல்லுங்க
four, five people are providing that camera. One is Professor Payus Augustine. I am not seeing him in the thing. He may be there. Dr. Payus Augustine. He has 25 years experience. He is from Cochin. Yes.
Kulkarni sir, please unmute yourself.
Kulkarni sir, please unmute yourself. सर आपकी आवाज नहीं आ रही है.
Dr. Madhusudan, as a host, you can unmute him.
Yeah.
Yeah. Sorry.
Yeah.
Okay.
Dr.
Please go ahead.
Hemant Kumar from Solan, Himachal Pradesh, and finally Dhwanil Kapadia, who is the youngest person, we chose him as an observer as to know what are his views on what is happening. So this is our team of observers. Then there are the two secretaries, RC22, Dr. C.H. Madhusudan from Warangal. He has already introduced himself to us. Uh, please welcome him. And also the EC member from IAPT, Dr. Rajeshwar Rao, who is also here, Dr. Rajeshwar Rao from Hyderabad, Telangana. So these are the people who are behind the desk. They are doing a lot of work. And so this we have a team of volunteers, team of observers, and team of technical people. All these will be giving the show. I am only just somebody who coordinates things. I have not done much. Most of these people have put 99% of effort, and my coordination is hardly about 1 minute. So with that, I close my introductory remarks and hand over to Dr. Reshma. Thank you very much.
Thank you, sir. Thank you for giving this brief introduction, and also thank you for bringing all of us together to hold this workshop. And this was really completely your idea and very nice thoughtfulness to bring this workshop to all of us. Thank you again, sir. Once again, I will now invite Dr. Professor P.K. Aluwalia, President, National IAPT, also the patron for this workshop, to kindly deliver his welcome address.
Thank you, Dr. Reshma, and dear participants of this workshop. I'm very happy to be with you this evening. Thank you, Professor Arvind Kulkarni, for breaking the slumber of people around in IAPT. You have been really doing that task in a wonderful manner, and you are bringing new ideas also, which are very, very crucial for the physics community and beyond that also. Thank you, Dr. Madhusudan, for taking the responsibility of once again organizing this program. Let me tell the audience present here that Dr. Madhusudan also coordinated a very interesting program earlier that was on whys and hows of teaching quantum mechanics at undergraduate level. So thank you for taking this initiative once again. Coordinator of this course, Professor Vandana Luthra, my colleague in the executive of the IAPT, General Secretary of the IAPT, Dr. Rekha Ghorpade, our very esteemed guest, Dr. Karthi Ganesh, and the members of IAPT community, students from schools especially that you have shown interest, the students from colleges. Dear friends, your life is going to be very comfortable if you will start looking at these opportunities which are waiting for you, because we are in a decade where quantum computing is going to rule the things around us. Also, I would really welcome our postgraduate students. They are the ones who can benefit immediately a lot and think of doing something in this area immediately. Also, dear fellow teachers, it's a great opportunity for you to learn and take initiative in your educational institutions to talk about quantum possibilities which are now coming up. It is very essential that we bring awareness about this kind of a program, this kind of a subject, this kind of an opportunity. If we really want these things to percolate down, it's very essential that even a common person should be given an awareness about these technologies. And we as physics people, definitely things are getting initiated by us only, not just today, but for many, many decades, rather a century has passed in talking about quantum mechanics. I see this program as a kind of a trigger for follow-up programs also. I know when this program was being planned, a lot of effort has been made by the group led by Professor Vandana Luthra and catalyzed by Professor Anand Kulkarni, because that is how it is happening. I'm also happy to see my senior colleagues from IAPT also participating in this program. That is a very encouraging sign for us. In the last 2-3 years, what we have seen is that this technology of meeting together right from our own places has made us learn very many new things in a very, very comfortable way. And I think that is how IAPT can make a mark also in changing the environment of learning beyond the classroom also. So we have started going in modes of in-person programs as well as offline. But offline brings people together in a very convenient fashion. And we can do everything in this mode, which is possible in a typical classroom. So thank you very much for giving me an opportunity to talk to people in this particular program. I welcome you once again, and I hope you will have a very interesting learning experience, which will take you beyond just listening, but getting into the mainstream of quantum revolution too. Thank you.
Thank you, sir, for your kind address. Moving ahead, may I now request Dr. Rekha Ghorpade, General Secretary, National
Rekha,
I.
Rekha told me she will not be available. She is locked up in some other work. She
Okay.
excused herself. So let us move on to the introduction by
Okay. Yeah.
Vandana of the speaker. Thank you.
Yes. Yeah. I will request Dr. Vandana Luthra, the course coordinator and also one of the speakers for this workshop, to kindly introduce our chief guest for today's function, Professor Karthi Ganesh Durai.
Thank you, Dr. Reshma, and my greetings to all the dignitaries and the participants today. It is and the guest, Dr. Karthi Ganesh. It is my delight and privilege to present biography of a leading professional in the field of quantum computing. Dr. Karthi Ganesh has completed Masters of Business Administration from Pondicherry University, and he has completed DOE ACC B-level examination, which is equivalent to MCA in India. He is working as Chief Quantum Architect at Iapt Qc PSI Private Limited in Bangalore, and he's working on quantum machine learning, and he's a mentor at Atal Tinkering Lab. He has conducted quantum computing classes for school students in US through Silicon Valley Quantum Group, California, and has conducted 8 FDPs sessions on quantum computing since 2021. He has been visiting faculty for quantum computing in various cities in India, and he has completed numerous edX courses on building blocks of quantum computing 1 and 2, and he has hands-on experience on IBM Qiskit and Penny Lane for building AI problems. He is an active follower of quantum computing industry since 2004, and Dr. Ganesh, your vast experience in this field is pertinent for this cohort of participants who have passionately joined this course and are eagerly waiting for your talk. And they will also learn from knowledge to applications and how to actually see this transition and what kind of skills actually you have, which is useful for this kind of field and transition. It is my pleasure to invite you for the much awaited talk, and over to you, Dr. Ganesh. Thank you.
Thank you. Good. Great.
Thanks to all. Can I start now?
Yes, you can start.
Yes.
Okay, let me share my screen first.
Yes, sir.
Hope my voice is clear. You are able to
Yes.
see my screen, right?
Yes, sir.
Yeah. So it's a great privilege, and then I'm thankful to Dr. Arvind Kulkarni sir and all the dignitaries in the IAPT for giving me the opportunity. Let me start with uh, this is what you're seeing now is global efforts for quantum technology in 2023. It is $36 billion. It's not simple money. In India, you can see it is spending around 1 billion, which is 8,000 crores, which is 6,000 for quantum technology, 2,000 crores for AI. Obviously, it tells you there is something big is going on the quantum technology. That's why we are seeing $36 billion is put into this effect. Let me show. Actually, now everyone is talking about this much of money they are investing. What is the really quantum computers are there? Yes, this is one quantum computer from IBM. We called IBM Q, and this is another quantum computer from Google. It is called Sycamore, and then this is another quantum annealer. It is not full-fledged quantum computer. It is called quantum annealer. It is from a Canada-based company called D-Wave, and this is another quantum computer from a company called Rigetti. And here is another quantum computer called IonQ. It is based on trapped ion. Whatever we have seen, they are superconducting quantum computers. This one is from IonQ based on trapped ion. And this one is from Xanadu, again Canada-based company. This is a photonics, optics-based quantum computers. And this is Intel-based quantum computing using superconducting technology. And Alibaba from China, they are also building. So Microsoft trying to build topological. I think this number of examples are sufficient for us to start believing that quantum compute is real and it is now. And this is right time to enter into quantum computing career. Those who are entering now, they will have the early entrant advantage. That is what is I'm enjoying now. So I invite all of you to explore this field because within the 20 minutes, I can give so much of introduction only. Just these images will give you a confidence. Yes, we are going to learn or we are going to pursue something real and then something there are working quantum computers are available in the market. Though they are costly, it is real. And then this much of companies are working on quantum computing technology on various. This is all hardware side. These are all hardware side. These systems, and these are all quantum processor, and these are all software side. And here it is application and the end user. If you see the end user, Airbus, JB Morgan, Volkswagen, Boeing, these are all organizations trying to embrace quantum computing for their research and certain class of problems, which we are going to discuss in subsequent slides. So whatever we are seeing now, I believe that is giving you a confidence. Yes. Now, this is national level ecosystem. Here you can see our company also here, Mosan QSI. And this is the government initiatives. And then these are all the service providers. You can see almost all top Indian consultancies are there in the soft service provider. And then all tier one, tier two, tier three colleges are contributing to quantum computing. So this is the quantum computing ecosystem in India. If you try to get this 2 years back, you cannot find it. But now the quantum computing gaining a lot of momentum. Now you can see many Indian organization also able to contribute something to the industry. Now, after seeing all these things, you may feel more confident. Okay, I would like to learn quantum computing. It looks like a promising thing. If that is the case, this should be your learning path. First, you have to identify what is your domain. Being from physics background, you are suitable for hardware, or else you can go for optimization or simulation or QML, cryptography, finance, any one of the domain you can choose. After identifying the domain, we have to understand how the physical system is manipulating the numbers or performing some operations from the physical system perspective. Then understand the same physical system behavior in the mathematical model, which is involves linear algebra, complex number, Hilbert space. After understanding these three things, try to learn programming language. Now the twist. After learning the programming language, most of the time you are going to work on the programming language. Now you got the point, right? We have to start from domain, physics, mathematics, programming, but we have to focus more on the programming. As a physics professional, you have a strong understanding of the physical system and mathematical model. When it comes to implementation, we need programming. And if I have an opportunity to select two resources, one is a software engineer, other one is a physics. I prefer physics person for quantum computing projects because the physics person able to come up with a lot of solution which is nascent technology, because quantum technology is a nascent technology. Software engineers are suitable for matured industry because they can build a solution for the mature thing. But the research nature, it comes from physics resources. Now you got the point, right? Most of the time, industry people either preferring mechanical students if it is engineering, or physics if they are from science stream. Software engineers are used as support resources. The mechanical engineer, physics researchers will give the solution for that model. The software engineer build it. If a physics person learned Python programming, they can do both. You got, hope you understood, right? That is where this session, this learning path will help you. Learning Python program, it will take only 3 weeks to 4 weeks. You can learn it. Then apply your physics knowledge. You will become invincible in the quantum computing solution development. With this given us then what you have to learn. Okay, this looks good, KG, but what I have to learn? We learned Python programming. What I have to learn as a Python, physics professional? You have to learn certain algorithms. These are all fundamental algorithms like Dijkstra, Bernstein-Veserani. These are all the basics which are in the left side. And right side, you can see these two algorithms, Shor's algorithm and Grover algorithm. These are the most popular algorithms which made the industry realize that quantum computers are much powerful than supercomputer to deal or to solve certain class of problems. Not all problems. See, we won't use quantum computer for database management or graphics manipulation or image creation. We will use quantum computer for solving certain non-polynomial time problems. We call it as a NP-hard problem. So non-polynomial time problems are very hard to solve by classical system. Classical supercomputer can take 4 years to crack a secret key, security key, but a quantum computer can break it. A quantum computer of 10,000 qubit to 1 lakh 1 qubit can break the key within 4 minutes to 8 minutes. That is the quantum advantage. It is called quantum supremacy. That is what in September 2019, Google claimed we achieved quantum supremacy. That is when most of the industry people know, normal people came to know that there is something called quantum is gaining momentum. So this chart, what I am showing here is the roadmap from IBM, which is starting with the 2023. Then they are going to 2030. So the industry is predicting 2028 is the end of first generation of quantum computers. We are in the first generation of quantum computers. Remember 1980s. During 1980s, when someone told that I am going to pursue computer science as a career, no one agreed for that one, correct? Because that is a nascent stage. No one believed what kind of job they can get in. But now everyone is looking for computer science as a career. Same thing. Now quantum computing is in the entry stage or first generation of quantum computers. 2028 to 2039, we will see second generation of quantum computers. 2038 to 2040 and the 2050, we will see third generation of quantum computers. That is where quantum computers used to build supercomputers. You can see here this 2030 IBM plan is to deliver quantum-centric supercomputers. So with this one, I would come to my favorite movie. This is one scene from a movie called Transcendence, where Morgan used to tell the above line, quantum computing, this is astounding. That was told by Morgan. The side, whatever you're seeing, the light white line, these are all quantum processors, optical quantum processor. Of course, it's a science fictional movie, but in this movie, Johnny Depp conscious will put into an artificial intelligence system that AI will build this quantum system. So it is like AI will help quantum, quantum will help AI. That's what mutual helping. Like that's where my field quantum machine learning. So with this introduction, I would like to confirm you one thing. Physics professionals, if you learn Python programming and seriously pursue quantum computing as a career, you have the upper hand in this job market compared to software engineer. Because I myself experienced explaining the problem to a software engineer than a physics person. In my personal training, I'm training applied physicists and master's physics. They are all really very fast pickup. And had with a proper Python programming knowledge, they are able to build simulation system, optimization system, and machine learning system. With this, I would like to confirm you that you are in the right direction if you choose quantum computing as your career. Over to you, Professor Arvind Kulkarni sir, and other. Over to you, madam. Dr. Reshma, madam. I'm done with my session.
Yeah.
Thank you.
Yeah. Yeah,
Thank
it's
you.
a great presentation, and I expect Karthik Ganesh to help us in expanding our domain. That is, we want to reach larger and larger people, and he's going to tell us how to do that. He's going to advise us. And with this, I take you back to Reshma. Yeah, Reshma, bye.
Thank you.
Yeah.
Bye.
Yeah. Thank you, sir, for this introduction to this workshop. And I think I must say that your talk has set the tone for this 1 week program, and all the participants must have got an idea exactly where we are heading to. Thank you very much, sir, for your very nice address. Thank you. I will now invite once again, let me invite Dr. Vandana Luthra to give us a brief about how this workshop flow will be. Dr. Vandana Luthra.
So much, and my greetings to everyone again. I am thankful to Dr. Arvind Kulkarni for initiating this initiative and the continued support of Professor Aluwalia and Professor Rekha in this endeavor is exemplary. A dedicated team was formed comprising of myself, Dr. Abha Khandelwal, Dr. Rajiv Tyagi, and Dr. Jyoti, and Dr. Kiran, and Dr. Balakrishnan. The enthusiasm of the team is amazing. Like, I really say my kudos to everyone. And I'm thankful to Dr. Madhusudan and Professor Rajeshwar Rao from RC22 for hosting this event, and Dr. Reshma and your team for the wonderful volunteering and today comparing. And also, my views on this echoed very well with the fact that there is a need for such workshop for school students. And this has been also possible due to dedicated team of the resource persons. Like the revolution was there in the diodes and the transistors in the last century, which has directed the technological advances. And now there is another wave of technological advancement, and that is quantum computing. With the launch of National Quantum Mission, the pace of developments in this field will be manifold, and so will be the demand of the skilled persons. This course is a way forward in this direction. So demystifying quantum computing, which has been targeted for the secondary school students and beyond here would mean unbounded. And this is weighted by the number of participants, which is 113, and is representing school students, UG, PGs, teachers, and many professionals also. I wholeheartedly welcome the participants. And with the inspiring talk of Dr. Kirti Ganesh has set the stage on for the further deliberations. And this workshop is going to be very basic with a wide range of participants and their backgrounds. It will create an ecosystem of ambassadors of the quantum computing and future advanced workshops for the college students and the teachers will be on the way as an outcome of this. Being an interdisciplinary field, as just shown by Dr. Kirti Ganesh, that this will induce the need for the skills generation in the students, and skills would mean that they need to know some knowledge of mathematics, for computer science, optics, and they need to have many other things like programming language. Other than that, material science is also playing a very important role in this. So, and nanotechnology also, engineering also. So, interdisciplinarity is there. And with the my prayers to the Almighty for seeking the blessings, we will be today beginning with the first session that will be on superposition. In the forthcoming sessions, we are going to talk about different experiments which create superposition. There are many experiments which will be taken care by, and we will be also having a lecture on transition from classical bits to quantum bits, followed by there will be a session on cryptography, and then we will be talking about quantum circuits. And this will be, again, we will be having sessions on like entanglement and teleportation, and many such things will be coming one by one. And we will be demystifying this word of quantum mechanics, which is entirely different from the classical mechanics. So with this, I pray to the God for the success of the conference, of this workshop, and greet everyone again. Over to you, Dr. Reshma. Thank you very much.
Thank you, ma'am, for the brief introduction of this entire workshop for us. Thank you. Moving further, we are all ready to start and learning the quantum computing from the basics. But before moving ahead, I must say bringing around 130 participants on one platform has been a great work, and there are a lot of people involved in organizing this event. And to propose both of them, may I request IAPT Treasurer of RC22, Dr. Rajeshwar Rao, to do the honors of proposing vote of thanks for the inaugural function. Dr. Rajeshwar Rao, are you there?
Am I audible now?
Yes, sir, you are audible. Yes, sir, you are
He is an EC member to IAPT and not the treasurer. That's a minor correction. Yeah.
Okay, yeah, thank you, sir.
No, not an issue, sir.
Yeah.
It's not a big problem. Good evening, everyone. Honorable dignitaries and friends. Really, one thing I could recollect all years back. In 2005, we have conducted a seminar on emerging trends in physics, remembering 100 years works of Einstein. One of the topics that we took was quantum computation, and that was dealt by one of the eminent personality from Kakatiya University, Dr. A. Ramakant, who is an expert at that moment. And still I had that copy. To announce it, I have just get it. And it is a very good, when my colleague Madhusudan called me, sir, this is the opportunity that we are going to get. And I said, you take the advice of Professor Ahluwalia, sir, whom is a, I'm sorry, who is the right person to advise us. And it has realized a wonderful effort of Kulkarni sir and other people. And I really appreciate the effort. And one thing that attracted me is focusing on the student community, that is at 10 plus secondary school level, 10 plus 2 level. This is, I think, after Ahluwalia sir took over the things, really he made many things to happen. This is the second such workshop that we are conducting on our platform. So I thank each and everyone for making this program possible. More than 113 participants and students ranging from secondary school level to
I
PG
know the
level
wild animals. How do they go to the wild?
to PG level and teachers, wide range of students and faculty members. It is
Hello.
going to help us a lot,
Hello.
everyone.
Yes.
I thank each and everyone for attending.
Yes, but now it is
Thank you
going on.
and wish you all
can
the best to all of
try
you.
to connect later on. Right?
Thank you.
They'll just be like, yeah, Black Americans are
Thank
also better. You should describe them. Then we have the one. Yeah,
Yeah.
Thank you, Reshma ji.
Yeah. Thank you, sir. Thank you very much. Rest all participants, please mute yourself. Dr. Lindam. Yeah, thank you so much. Thank you very much, sir. Okay, so we now begin with our first session that will be delivered by Dr. Jyoti Qc, who is a PGT physics teacher at PICT Model School, Belawadi, Pune. Before inviting her to start her session, I will give a very brief introduction of Dr. Jyoti Qc. Dr. Jyoti Qc is an enthusiastic physics teacher, 13 years of teaching experience. She has worked at Priyadarshini Engineering College, Nagpur, and in Cummins College of Engineering, Pune. She was a university topper during her graduation and has received around 9 gold medals. She has completed her PhD from VNIT Nagpur. She has cleared her SET and GATE examinations, and she's very much passionate about physics teaching, and she believes that physics is a subject of experimentation and keeps motivating her students for more and more hands-on activities. We are very honored to have you, ma'am, as one of our resource person, and I hand over to you to begin today's session. Dr. Jyoti Qc.
Thank you so much, Reshma ma'am, for a very grand introduction. First of all, I would like to thank all the dignitaries for the opportunity for conducting today's very first session. Thank you all, the convener, the organizers, the IAPT members. Thank you so much for your support and guidance. Thank you. I would like to share my screen so that we can actually start with the presentation. Is my screen visible?
Yes, screen is visible.
Yes. So welcome to Demystifying Quantum Computing, this course specially for secondary school students and higher level. I'm Dr. Jyoti Qc from PICT Model School. I take this opportunity to begin the session, the very first session. Now, quantum computing is a growing field at the intersection of physics and computer science. In this module, basically, we will be talking about 3 principles of quantum computing that include superposition, quantum measurement, and entanglement. As already told by our convener, Dr. Arvind Kulkarni sir, the motive of the course is to provide a foundational understanding of quantum computing, inspiring curiosity and fostering enthusiasm for this cutting-edge field. The course aims to ignite a passion for STEM disciplines, science, technology, engineering, and mathematics. It will encourage critical thinking and it will empower participants to clearly understand the importance for pursuing their higher studies and careers in the fields related to quantum computing. Now, what are the prerequisites for this course? We need a little knowledge of electricity, magnetism, and waves from high school level. Introductory modern physics that includes photoelectric effect, wave-particle duality, that will be helpful, but again, it is not mandatory, or that can be learned at various stages during the course. And a little knowledge of basic probability for which online resources are available. So you can go to some good videos and you can just have the basics of probability, which we will require when we deal with quantum mechanics or quantum computing. Now, when we talk of physics, please tell me the screen is visible.
Yes, screen visible.
Screen is visible.
Yes, thank you, sir. So you can see various words written over here. I would like to invite my young learners who are desperately waiting for the session to begin. So what all things that come to your mind when you talk of physics? Yes, it is mechanics, it is force, displacement, motion. Basically, we talk of day-to-day life activities. So physics is basically study of nature or the phenomenon, natural phenomenon occurring around us. It deals with waves, it deals with electricity, magnetism, lot many phenomena we study, and all the basics lies in physics. You can see you use various electronic gadgets which work on the principles of physics, the semiconductor devices. So physics is everywhere. If you see other branches of science, you will always find physics at the root. Means it is the one which will help you study other sciences. It is interdisciplinary. It is always linked with other different branches of science. Now, as Vandana ma'am has already given the overview of this course, I would like to briefly tell about what different topics we will be covering over coming days. It includes introduction to superposition. What is qubit? Creating superposition. So we will be discussing two experiments, two methods that will include beam splitter and Stern-Gerlach experiment, then quantum cryptography, quantum gates, entanglement, quantum teleportation, and quantum algorithm. So as you see, the flow of the course is also from basics to advanced level. Now, in today's session, we will be focusing on the very first topic, that is introduction to superposition. What are the learning objectives of this session? You will be defining the term first. What is superposition? What do we mean by the word superposition? And what it means for an object to be in a quantum superposition. So how superposition, the classical we define, and how it is different from quantum perspectives. We will mainly talk about the key terms like quantum systems, quantum state, then quantum superposition. So one by one, we will see what all these are meant for. The term superposition is used in different contexts. When it comes to physics, classically we define, like if we are talking of a wave, a crest and a trough, and another wave with a crest and a trough is superimposed on it. So it will result in the addition of amplitudes of the wave. So the concept of superposition basically deals with adding two physical quantities together. Now this addition is not simple addition. At times it is vector addition. The vectors are getting involved. Vectors are the quantities which have magnitude as well as direction. Scalars are the quantities which have only magnitude. So sometimes we will talk about the quantities which are vectors. So there will be vector addition for getting the resultant one. Another, when we are talking about, say, electrostatic potential, which is a scalar quantity, we will talk about algebraic addition. So I will give you a few examples to understand what do I mean by superposition. So let me take you to the simulation, the very first simulation, which demonstrates the wave interference. There are so many simulations available on this site. You can just type fate.colorado.edu and you can see several simulations based on physics, chemistry, biology, mathematics. So I have picked one to explain you what the superposition means. Now in this particular simulation, you can see there is a pipe. If I just turn on the knob, the water drop starts flowing through it, and there is a water body. When the drop falls on it, it generates waves. You can demonstrate, you can also create such a picture or such thing, the event, by dropping a stone in water. You can see the waves, they are spreading in all possible directions, 3 dimensions. It is called as spherical wavefront. Now, this is single one source we are considering. Now, if I consider another source, if I start, you can see a beautiful picture where at some places, the waves, they meet in phase with each other. There is addition of amplitudes, and somewhere you are able to see the dark spots where their amplitudes subtract and you will get 0 as the resultant. Now this picture will be more clear if I am considering a light wave. So let us replace this by a light source. Now, if you look at the first light source, say a laser beam, you can see the light, again the spherical wavefront moving ahead. And if I switch on the second light source, it will start interfering with the first one. And you can see somewhere you are getting a bright spot, somewhere you are getting a dark spot. Superposition, as we have defined, is addition or subtraction of amplitudes. Now that will depend whether the waves meet in phase with each other or they meet out of phase with each other. If I put a screen in front, let us see what is the effect. You can see somewhere the bright spots are formed and alternate bright and dark. So somewhere you will see dark spot. This was very interesting experiment given by Thomas Young to demonstrate wave nature of light. And that was the first time when light added to light gave darkness. So this is one example of superposition of waves. Let us return back to our presentation.
So what is the difference between interference and superposition?
In superposition of waves is when the waves meet, and interference is a special case when they meet in phase with each other. So there is constructive interference and destructive interference. Means basically to explain the phenomenon of interference of light, we use principle of superposition. Now this is regarding waves I am talking about. If I am talking about say electric fields, or if I am talking about magnetic fields, one magnet is placed and another magnet is brought near it. So the combined effect, so there the principle of superposition will be acting, which will result in the interference, in this particular case, interference of light.
So superposition and interference are same. Can I say?
See, we can interchangeably use, but superposition is a more general term. Interference we use specifically for say light waves or sound waves. So there we make use of interference.
Because of superposition, interference takes place.
Right. Because of superposition, interference takes place. Now let us move ahead with the second simulation. Now here I have taken 2 sound waves, and you can see if 2 sound waves of slightly different frequencies are sounded together, that results in, again, this is superposition. It results in phenomenon of beats. Like I will give you one day-to-day life example. In orchestra, several instruments are played together, but still we can identify the music of each. We can distinguish whether it is a flute or a guitar or tabla, and we can identify each musical instrument separately. Why? Because each one will produce its own displacement, and these waves will superimpose to produce some beautiful patterns. Sometimes beats are undesirable. So musicians, they try to avoid, they tune their instruments to not to have beat frequency, the little difference between the waves. This is another example of superposition. Let us move ahead with the third one. So this is third example which I would like to show. It is from GeoGebra. Now this is again very good application app where you can yourself see the various we can say patterns. Like if I choose a pattern where I'm considering a wave, this is a crest, the positive amplitude, and I'm selecting another wave with the part of it, a crest and a trough. I'm moving the two waves, the two pulses closer to each other. As they start moving, you will see that the resultant is sum of the pulses. You can see wherever they superimpose the resultant, here it becomes 0. Why? Because I have chosen exactly equal and opposite amplitudes. Now, if I just make them coincident, crest on a trough, you can see that the resultant pulse is having 0 amplitude. Their amplitudes get cancelled. You can play with various patterns over here to understand the term superposition in the context of waves. Let us return back to our presentation. Now let us redefine what is the term superposition mean. In classical physics, the concept of superposition is used to describe when two physical quantities are added together to make another third physical quantity that is entirely different from the original one. Now, whatever examples I have shown, they are related with the waves. But let us go to the next slide. Here, you can take the example of forces. Like if I'm considering three charges. Yes, any questions over here? Someone has raised the hand, I think. Okay.
No, it was just an appreciation. Go ahead. It was just an appreciation
Okay.
of the fact that it is a wonderfully structured program. Thank you.
Thank you, sir. So, figure 1 is again the same example of constructive and destructive interference. The simulation which I just showed using GeoGebra, you can see the crest and crest falls on one another. It will add up to give a crest of larger amplitude. Crest and trough fall on each other to give a destructive interference. One day-to-day life example I would like to share over here. Suppose you are playing, you are swinging on the swing, and your naughty friend, he comes and stands just in front of you. When you are moving ahead, he comes and starts applying force in the opposite direction. So what will happen? Your amplitude will decrease. But suppose he is standing behind you and is trying to push you ahead, naturally, both the forces are in the same direction. They will add up to increase the amplitude. Now, figure 2 is an example. Again, this is a classical superposition. I will come to what quantum superposition is later. So everywhere I'm putting a word classical here. The superposition is used to calculate the total electric force on charge Q2 due to charges Q1 and Q3. Now this we generally learn in standard grade 11 or rather in grade 9 also. There we study Newton's law of gravitation. So there also we make use of similar superposition principle. Here we are talking of Coulomb's law, which states that if we are considering 2-point charges and they are separated by some distance, like in this particular case, I can see the charge Q1 and Q2 both are negative. So they are repelling each other. Force on Q2 due to Q1 is indicated by F12 force, whereas Q3 is a positive charge, so it will attract the charge Q2. So force is towards Q3. Now these two forces are simultaneously acting on Q2. So what will be the resultant? So here the principle of superposition will play a role. We will add the vectors. It is a vector addition. So we will have to apply, means we will have to take into account their magnitudes as well as direction. So the resultant is given by triangle law of addition of vectors, or we can use parallelogram law of addition of vectors. So F total is the resultant force. Moving ahead, now let us test. Now the audience is sitting calm and quiet. Let me involve them. I want you all to please go to the site www.menti.com and you have to use a code to answer the question. There you have to write one example of classical superposition. If you are not able to use the code and go on the site, you can write your answers in the chat box. The So I can just put over here the code also. You can use this code and you can write one word, one example. Now that example, let us go to the Mentimeter and see what beautifully you have written. I have I will just check what all answers you have written over there. So I will just share my screen. Let me share the entire screen so that you can see. Wonderful. So many responses. Some of you have written, yes, sound waves, static charges, beats, water waves, net force. Fantastic. So I hope you have understood what is classical superposition. And let the responses, you can go on giving more and more responses. You can write your answers in the chat box. Let us move ahead. Let us come back to our presentation. So I will just take you to the next slide. After understanding what is classical superposition, let us try to understand what quantum superposition is. As I said, quantum superposition, let us first focus on the word quantum. Quantum superposition is a phenomenon associated with quantum systems. Let us first understand what do we mean by quantum systems. Now, suppose you are studying Newton's laws of motion or you are applying the equations of motion to solve some day-to-day life examples where you want to determine the final velocity when the initial velocity, acceleration, time is given. But if suppose your particle, say a car or any object, a ball, is replaced by an electron, by elementary particles, very, very small particles whose mass, suppose I consider the mass of electron, you will not surprise if I mention the value. It is 9.1 into 10 to the power minus 31 kgs. If you're talking of such a small particle which is not visible with naked eyes, how you're going to apply the Newton's laws or equations to determine the position or velocities? In that case, quantum theory plays a very, very important role. So small objects such as nuclei, electrons, elementary particles, photons, which exhibit wave-particle duality. I will explain what wave-particle duality is, but where non-classical effects are observed. So in all these systems are called as quantum systems, and their rules are very different from the classical one. Classical one means where the Newtonian mechanics we are applying. The special feature of quantum mechanical systems is energy is quantized. Let me give you one simple example. As you can see in this figure, where two persons are shown, one is climbing on a ramp, another is climbing on the steps. So what is the main difference? Main difference is in quantum mechanical systems, energies are quantized. They are in the form of small steps. The person which is climbing on the ramp can put his foot anywhere he wishes to. It means that in terms of quantum, say energy considerations, we can say it can have any value, any amount of energy possible. But suppose this person who is climbing the ladder or climbing the steps, he can put his foot on the first step, then on the second, then on the third. he cannot put it anywhere in between. You can imagine a situation where ladder is there and there are steps and there is nothing in between where he can put his foot. So in that situation, it is quantized. Only certain specific values of energies are allowed. All the energies are not allowed. Another example, which we generally study when we talk of quantum theory, is hydrogen atom. In hydrogen atom, you will learn that energy is given by minus 13.6 by n square electron. Now, for my young learners who might not have been studying this formula before, so this is a formula, just like we calculate kinetic energy in classical, say half mv square, or potential energy we calculate by mgh. So when you study in grade 12, grade 11 and 12, you will learn about this formula. Now here, even if you don't know, you can only understand the thing that energy is inversely proportional to square of n. And what this n is the principal quantum number. So if I'm considering different orbits, how the energy will change in each orbit. So suppose I take n is equal to 1. This diagram, the diagram which is shown just besides it, it is showing the energy levels. When I say n equal to 1, it is showing the ground state. Now, when I take n is equal to 2, definitely you will put here the value of n as 2 and you will get minus 13.6 by 4, which is nothing but minus 3.4 electron volt. But is it like that there are no energy levels in between? No. Energy levels are there, which are present in between n equal to 1 to n equal to 2, but those energy levels are forbidden, which are not allowed, and the electron can only occupy the ground state, or it can be in the first state, first excited state. It means that the energies of hydrogen atom, they are quantized. It can take only specific certain amount of energy. Not all values are possible. Let us move ahead. Now, how classical physics goes different. So if you see the big systems, if you just consider n very large, say I am taking n is equal to 100, then 100 square. So you are dividing 13.6 minus 13.6 by 100 square. So definitely, if I am talking about the energy levels 100 and 101, so the energy difference is so small that it is just negligible and we can take them continuous. Means if we are going to the big systems, macro systems, you will find that energy levels, though quantization is there, but at classical level, big systems, we will not be able to measure that difference. So we take it continuous. So this is regarding what are quantum systems, how they are different from classical system. Now let us again come back and see what our superposition is. But before that, okay, let us, one more feature we will discuss, which is wave nature of matter. Now, when I say electron is moving with some speed. How much can be the speed of electron? It will not be just like our vehicle speed, say 40 kilometers per hour, not like that. It is 10 to the power 6. So it is comparable to speed of light. It's moving so fast. So de Broglie, a French physicist in 1924, put forward a bold hypothesis. Now, why this is called as a hypothesis? Because he did not give any experimental evidence. He observed the symmetry. That time, see how the historical development was. Maxwell's equations were given and unification of electricity, magnetism, and eventually it was found that light is an electromagnetic wave. So people started thinking of nature of light. They defined light as waves. Certain phenomenon were explained by considering light as wave nature. Certain phenomenon, like I mentioned in the very first slide, that photoelectric effect, Compton effect, where we need to consider the particle nature. So there were two trends where people started thinking that it is wave or it is particle, but both the views were correct. And therefore, it was finally settled at the case that, yes, light exhibits dual nature, both particle as well as wave. Now, what de Broglie did, he said, yes, if it is true for electromagnetic radiation, say light, then it should be true for material particles. and therefore he proposed a hypothesis that any moving particle of matter displays wave-like properties. So if I'm considering an electron, that will be moving, that will be having a wave associated with it. Now, how this wavelength depends on the momentum. So it was found. Now, let us not go into the mathematical details of this. This you will learn as and when required. What my point is, wave nature of matter resulted and was proposed by in 1924 by de Broglie, and that was significant at the microscopic level for subatomic particles. Why? Because if I consider wavelength inversely dependent on momentum, so if I'm talking of big objects, massive objects, definitely the wavelength will be very small, and therefore it will not be measurable. I've just mentioned here Heisenberg's uncertainty principle. Again, in the coming sessions, you will talk about this in detail in later. But the beauty of this is, as you go to the quantum systems, you will find that it's not possible to measure both the position and momentum simultaneously with 100% accuracy. Like when we apply equations of motion, we can determine the position where the particle is, and at the same time we can tell what is its final speed or initial speed. But if we go to the subatomic or microscopic level, we will find that these particles, say if the electron, which is moving at a speed of say 10 to the power 6 meter, 1 million meter per second, and if you want to find exact location, you will have to slow down. So when you are slowing down the electron, definitely there will occur an error in the measurement of velocity and hence in the momentum. So simultaneous measurements of both position and momentum for these particles will not be possible. We will more focus on this later. Now, let us coming back and let us again ask our audience how much they have understood about quantization. I am using the word quantization again and again. What are quantization of energy? So let us discuss whether following quantities, they are quantized or they are continuous. I will just show the question first. I want my dear participants to write the answers in the chat box, and then I will display the answers so that you can check whether your answers are correct or not. Ready? So let me show you the very first quantity, the electric charge. You will just type your answer in the chat box, and what you have to type, whether it is quantized or continuous. The second one, time. Third is length. And fourth is angular momentum. I will give you a time of say 30 seconds to write your answers A, B, C, D, whether it is a quantized quantity or it is a continuous quantity. Just think and give your inputs. Okay, thank you so much for your inputs. Let me show you the answers. You can check your answers, whether you have given correct answers or not. So electric charge, as we have discussed, is quantized. The smallest unit is electron, which is 1.6 into 10 to the power minus 19 coulombs. And the charge is always an integral multiple of this basic unit. So it is represented as plus minus NE. Time is continuous, length is continuous. Angular momentum is moment of momentum. In quantum mechanics, we define it as nh by 2 pi. So we say it is again integral multiple of this h cross Planck's constant. So that is also a quantized quantity. Thank you so much for your quick responses. Many of you have correctly answered. Okay, moving ahead to the next slide. Now, what is quantum superposition? So we started with the introduction of word superposition, various classical examples for it. Then we defined what are quantum systems, what are its features, various examples for quantum systems. And now we will land on our main topic, that is quantum superposition. So the question is, what state is the coin in while it is in air. Suppose you toss the coin. What you will see? You will either see a head or a tail. So but now we are asking the question that if the coin is in air, will it be head or will it be tail? You will be only able to tell definitely the state when it lands on the ground. So when we can say that coin is in a superposition of both heads and tails. When it lands, it has a definite state, either heads or tails. Broadly, the word state, I'm again and again using the word state. That state means any particular way that a system can possibly be described. For example, when I say hydrogen atom, the electron is in the ground state. So I will quickly understand that yes, it is having minimum amount of energy. If it is in the first excited state, it will have minus 3.4 electron volt amount of energy. Now, coin can either be showing heads or tails. So this is a state. A combination of heads or tails when flipped in air. That is again the state. For all these cases, we are using the word states. So a quantum superposition, when the coin is in air, we will talk about probability. Now, what is written on these arrows? 50%, 50%. So when the coin is in the air, you will predict whether it will be a head or it will be a tail. So out of 2, your output will be either head or tail. Means it is 1/2 or 50-50 chances of getting a head or a tail. The measurement destroys superposition. So what a quantum superposition means? The quantum superposition, this quantum system, it can exist in superposition of these definite states like both heads and tails simultaneously, and each one will have some definite probability. But when the coin will land on the floor, then only you will be able to tell, means the superposition collapses in that case. The outcome of measurement is to observe some definite state with given probability. So you will get quantum superposition only when it is in the air, when you are not exactly seeing whether it has landed with a head or a tail. So any system which can be described this way will show or will exhibit quantum superposition. Now let us see this very interesting example, which is the Schrodinger's cat. In Schrodinger's famous thought experiment, now this is a thought experiment. We are thinking that there is a box, which is a closed box, and it is emitting deadly radiation. And how it is emitting deadly radiation? Some probability, definite probability that the radiation, single atom, it will emit at every instant. The cat is alive or dead, that you will know. You don't know whether it is alive or it is dead. You will only know when you open the box and you look inside. That means the cat is both alive and dead with some probability. Unless and until you open the box and peep inside, you will say it is in quantum superposition state. Why? Because it can be alive, it can be dead, and both the things or both the cases will have some probability. Now, when you measure, when you open the box and peep inside and see, then that superposition collapses into a definite non-superposition state. Means whenever you are not seen, you are not knowing definitely the superposition exists, which is quantum superposition. And what is quantum over there? We are talking of probability. We are talking of chances. We are not definite. We are not sure that yes, it is dead or it is alive. We are just predicting the outcomes. So that is called as quantum superposition. Now, how a quantum system is different from classical. So classical state is always a definite state. So many examples we have seen. Everywhere we talked of a definite state. Yes, the particle is, or the forces, they finally add up to give you this value. Or amplitudes, they add to give you maximum or zero, like that. But quantum systems can exist in superposition state with each having some probability. Measuring the system will collapse the superposition state into one definite classical state. So what is the summary of what we have learned? A particle in a quantum superposition exist as a combination of different states at the same time. And whenever you make any measurement, that will destroy the superposition because only one state is seen with a given probability. Like if I toss the coin, when the coin is in the air, I will predict that yes, 50% chance of getting a head, 50% chance of getting a tail. So I can write both the states with half probability, 1/2, 1/2. But when the coin lands, I will either get a head or I will get a tail. Means that superposition has destroyed, the measurement has destroyed the superposition, and now it is giving you a definite state with some definite value. So this is all about today's topic, introduction to superposition and what is classical superposition, different examples, what is quantum systems, what are quantum systems, what is quantum superposition, and how quantum superposition is different from classical superposition. So always we have to keep in mind that there will be always the uncertainty, the probability we will talk about. We will always represent the state with 2 or 3 or many possibilities, multiple states at the same time with some definite probabilities. So if you have any questions, the session is open for question answers. Please, you can unmute yourself and ask.
Ma'am, yes.
Yes.
My name is Daniel. I hold a master's degree in physics. One thing I had a doubt, you said the time is continuous, right? But each time is actually, it is having, what is it, let's say, take an hour, it has only 60 minutes, not more than that. Then it means it's quantized, right? Like, I did not understand about the quantized and continuous. I did not understand that alone. What do you mean by quantized? What do you mean by continuous? Is there a possibility for you to give an explanation?
Quantization of energy, I gave an example of, say, hydrogen atom.
Yeah. But
So,
even when we take time, each minute has seconds, right? It is defined,
yes.
correct? So how can you say that that is continuous? That's what I'm.
But time is continuous. You can break even second into milliseconds and microseconds, and to the smallest of it, you will see that it is not something which is not allowed, right? It is 1 minute and then you have
Okay,
to.
now I'm getting it.
Yeah. You can
Yeah.
count every fraction of it like that.
Okay, I get it.
Right. Any questions from audience?
Hello, ma'am. Is my voice is audible?
Yes. Please ask.
I want to ask you one question. So superposition means it is like a prediction that whether it is means it is not in existing state.
The quantum superposition.
Yes, madam. Quantum superposition.
Yes.
So how it is applicable to quantum means if it is not existing.
See, this is very first session where we introduce the word. Now, second session you will learn about qubits, quantum qubits. So that is the beauty of the course. Every day you have to attend the lectures. So one day you will demystify the quantum computing. So you will learn the topic in detail, right?
Thank you, ma'am. You have explained in very nice language.
Thank you, sir.
May I come in, Rishma ji, may I ask question?
Yes, sir.
My pleasure, sir. Yes, sir.
Dr. Jyoti, it was a wonderful lecture.
Thank you, sir.
I really enjoyed it. Every bit of it I enjoyed.
Thank you, sir.
And
Sir, you are muted.
I think host had to mute somebody else. He has muted me. So you gave an excellent, structure. And I think now I was getting one more idea which was coming to my mind. I should really tell in this session itself.
Yes.
And that is this, that we should, after this course, have a small booklet which should be a conversion of these lectures into your documents, articles itself. Let us really move over to that kind of a level. Let me tell you that the way you explained that state which is in between the two things, you made it so obvious to the students, a very, very difficult proposition. I think hats off to your
Thank you, sir.
way of teaching.
Thank you so much.
And I also enjoyed your interventions of questions, very well designed questions, very nicely done.
Thank
I'm
you, sir.
really excited by this course. Let me tell you that.
Thank
We
you,
are
sir.
doing lots of experiments in IAPT these days.
Yes.
And I think we are getting better and better in coming out with excellent programs. And when it is targeted to school students, I think
Yes.
it cannot be a better thing than this.
Yes.
So
Thank
thanks.
you so much. Your words are really, really very encouraging, and you all are there to guide. Thank you so much.
I was clapping in between, when you were explaining. That was just so great.
Thank you, sir.
Thank you.
I just wanted to clarify one thing here.
Yes, sir.
Yeah, I just wanted to say that some student asked a question. When you say 2 plus 3 is equal to 5, which is very obvious, this is true only for numbers like 2 and 3. Now, if 2 and 3 are two different quantities of the same type, you get another quantity called 5. The existence of the togetherness of 2 and 3 is not same if the quantities are different. If the quantities are numbers, 2 plus 3 is 5 is correct. But if
Yes.
2 and 3 were two distinct different physical quantities or even mathematical quantities, it is not true that 2 plus 3 is always 5. It can be something else. This has to be understood. Once you get this point, you will know that what happens after the operation of addition can be anything. That is to be brought into the picture here. This is just for a clarification to the one of the questions from a student regarding the superposition. Thank you.
Any more questions from the audience? Okay, ma'am, there was some questions in the message box.
Yes.
Maybe I will just ask those. Right now, okay, that is already gone. There was one question which said, what does a phase mean?
Yes. Phase is state of motion. I will give a simple example. Suppose a particle is moving along the circumference of circle, and we learn in simple harmonic motion. I don't know how much the school children will understand, but suppose you are putting the light on that particle and shadow is seen on the diameter, then you will see that in going from, say, left to right, the shadow will move from left to right. The particle is moving on the circular path and its shadow is moving on the diameter. So when the particle follows a semicircle from left to right from the top, his shadow moves from left to right on the diameter. The particle comes again back to its original position from the lower circle. The shadow will move towards right. So on the diameter, there will be one point where the shadow will coincide, one where the particle was on the top, when the particle was at the bottom. So generally, when we say phase, in this case, the position, the place is same, but their phases are different. So the particle which is above the curve is moving towards left, where the particle is below the line is moving towards right. So that way we can say the states are different. State of motion is different, means the phases are different.
Yeah, I hope this has answered the question asked by participant. Another question was, what is Compton effect?
Compton effect is, again, it is X-ray photon when encounters with an electron, or it is a collision, elastic collision between an X-ray photon and electron. So again, the wavelength change was observed. You will see a change in wavelength because there will be transfer of energy from the photon to the electron. So again, the photon picture means we are considering the electromagnetic wave as particle. That will come into picture. So Compton effect you generally learn after 12th, the first year engineering or graduation courses.
Yes. Yeah. There is one more question. Why couldn't Einstein agree on the concept of superposition? This okay. This is
in context of what?
I don't know. The question just said why couldn't yeah. Okay, maybe we can go to the next question. Okay, there's a question by Sunita Singh. She's asking, how is this course going to help school teachers professionally?
It is very helpful, as you can see, and as was presented by our guest, today's guest. He has beautifully explored that if it is a physics person, he will understand the basics quickly, the quantum part of it quickly. So definitely, if you learn some languages like Python, physics and Python together, you can work in that industry. I mean, there is a lot of scope for teachers to take further this quantum computing.
Yeah. Are there any more questions from the audience?
Reshma, may I come in?
Yeah, sure, sir. Yes, sir.
In fact, Ma'am Sunita Singh, I think she asked a question, how it is going to help us professionally. I think in teaching, there are certain things which we must remember. The horizons of knowledge are expanding. And you very soon find that something which people were studying in PG, it is percolating down to undergraduate classes. And something people are studying at the undergraduate classes, it is percolating down to schools. So now I think if you attend these kinds of programs, it actually helps you to prepare for those kinds of situations which maybe you are going to encounter in your career as a teacher in a school or in a college. How it is going to help us on certain things. Sorry, so what I was trying to say was that professionally, it is going to definitely help you. There is an excitement in the mind of his teacher when he behaves like a learner, that, oh yeah, I also want to learn about it. There is a lot of talk about it in the atmosphere. After all, what is it? And students always come out with their questions, even when you are not teaching that thing to them. They may come to you outside in a corridor of the school or a college or a university and ask, sir, there is lot of talk about quantum computing and quantum entanglement and bits and qubits. We know about bits, but what is this qubit? How we are going to really understand that? I think this program, I'm sure, will help us clarify that kind of a thing. So please think of it not in terms of some monetary, gain, or even in terms of a certificate. It is much more than that. Thank you.
Yes. Thank you, sir. Vandana ma'am, you have a
coming to the last part, I would like to share the link for quiz, which I have created on the first session. So I will just share it. You can, I'll just copy this in the chat box. So you can take the quiz and check how much you can correctly answer.
Meanwhile, I will like to say that attendance of 83 in order to have a certificate and also a mandatory participation in the quiz is required. Am I audible? Am I audible?
Yes, ma'am, you are audible.
Yes. So
you are audible. You are audible.
Somebody has asked in the chat that the certification. So in order to get a certificate, it is required that you attend more than 80% of the sessions and take mandatorily part in the quiz. That is one thing which is the pre-requirement for getting a certificate. And also every day there will be a quiz based on what you have learned. And tomorrow's session is going to be from transition from bits to qubits. And we will again see superposition in forthcoming sessions also. And excellent work done by Dr. Jyoti. And if there are still more questions, you can always send it to us and we will try to answer those. So please take part in the quiz. It will take 15 minutes.
By Hemant Sistla. Please ask her or him what is the question. Hemant.
Yes. Thank you.
And please
Hello,
ask
sir.
her. Yeah.
Am I audible, sir?
Yes, you are.
Yeah, actually, I'm a pretty much enthusiast in physics as well as mathematics. So I just want to ask Jyoti ma'am about quantization in brief. May I proceed further, ma'am?
Yes, please ask.
Yeah, for example, if we assume quantization to be a function, exactly, that defines a state, to be honest. So my question is, for example, if we put any value in the function, any physical quantity, it should be giving just two answers in its codomain. Domain. Codomain. It is quantized or not. If we consider each physical quantity separately, like energy, momentum, etc. So when we put that value into the function and we would be getting the answer like it's quantized or not, then based on mathematics, my question is, can we classify few physical quantities under groups?
Basically, when quantization, what I have understood so far, or what I'm trying to explain, is classical systems, they are also quantized, but the difference is so small that you cannot measure it. It is not measurable. The measurable finite difference has to be there. So like for function, if you are saying only two values you are getting, so if other values they are forbidden and your system can have only these two values, then we may say it is quantized. Just like for hydrogen atom, I gave example that if it is in the ground state or excited state, in between these two there are several energy levels available, but the electron cannot occupy because it is not allowed, it is forbidden for it. So that explains the quantization for that system. So at microscopic level, it is level, it is measurable, it is observable. Whereas as we go to the big systems, macro systems, you will find that the difference is very small and therefore it becomes insignificant or negligible.
Yes, ma'am. Thank you, ma'am.
Makes it continuous. Yes.
Yes. Okay, we still have some time left. I will ask one more question, which was in the chat box. The question is, what is spectral series? Spectral series, ma'am.
Spectral series.
Yeah.
So for hydrogen atom, it is a transition, like Lyman-Balmer Paschen series. So Balmer series were invented first. Why? Because it is in the visible part of the spectrum. There were colored lines. If an electron, say, goes in the excited state, we are talking of hydrogen atom. So hydrogen gas, it is excited. It is given energy. So electrons will go to the higher energy levels. Now their natural tendency, the electrons will always try to come back to the ground state. So it will emit the photon. So again, we are talking of quantum structure, that we are talking of energy, photons, Planck's quantum hypothesis. So what it says, it will come back to the ground state, emitting the photon. So different series were found. So Balmer series is in the visible part of the spectrum. So that is spectral lines. So you can actually see using spectrometer. We perform these experiments in the laboratory and we can actually see the spectra.
Okay, yeah, thank you, ma'am. Are there any questions?
Reshma ji, one question. May I come in?
Yes, sir.
Actually, there was one question which was asked in between, That was that Einstein didn't believe in superposition.
Yes, yes.
Somebody asked that question. Actually, Einstein never said that he didn't believe in superposition. What Einstein was saying all the time was this, that he doesn't believe in the probabilistic foundation of the quantum mechanics. That is what was his concern all the time. That when people are trying to explain everything in terms of probability, he used to say that God never plays dice. Because, when man was showing that coin being flipped, it was like playing a dice only. So he was all the time saying this thing that, look, I feel that there must be some deeper meaning to it than just, probability. And fortunately or unfortunately, what has happened in the last 125 years since quantum mechanics started coming on the scene, we have found that this is working. And what we believe in physics is, if we are able to see it working with an evidence, then it works definitely. So that is the reason. And there is a lot of excitement these days on entanglement. And once again, people are talking about the famous paper of Einstein, written with his two other colleagues, of a paradox. So that EPR paradox, yes. So that paradox uh, was hoping that there will be some hidden variable somewhere, but the experiment said, sorry, they are not there, and you have to believe in what quantum mechanics is saying. So that is what it is. So this is small comment. You can think about it further also, but I thought that let us leave some idea for the student to think about. Yes, thank you, Reshma ji.
Thank you, sir.
I would like to say something here. What Professor Einstein said was, in a different situation, was something like this. He said that if I do not look at the moon, does the moon exist there or not? This is the thing that he said. That is true. And the other thing is about his probabilistic interpretation. Since things were very new at that time, well, some people can think like that. It's not nothing wrong in that. Thank you.
Yeah, thank you, sir.
Yeah.
Okay, so
Before concluding, can I have one sentence here?
yeah, sure, sir.
I just want to say that the ideas in quantum are not very easy to follow. They are not very common sense kind of a thing. So I request the students to repeatedly see this video again and again and impress upon themselves that what we are talking about is truth, and very, very hard truth, experimental truth. We are not talking about something that somebody's fancy or imagination. No, we will be doing these experiments further in the next courses, but the students should be getting more and more ready. So I request all the students, young and old, to make sure that the video, the class that was done. I mean, we will be sharing videos with you later after the classes, after the whole 10 sessions are over. Please study again and again and revisit the thing that will help in the progress of the course and your understanding of the content. Thank you.
Yeah, thank
That's
you,
all.
sir.
Thank you, sir.
Yeah.
Excuse me, ma'am. May I
Yeah,
ask a question?
yeah, please.
Ma'am,
Go ahead.
is there a
Or the
possibility to share any YouTube link or any record session or the PPT of what which was discussed? Is there a possibility for that?
As of now, there is no WhatsApp group has been formed. If it will be formed, everyone will get a link. And also the YouTube videos, as sir has just told, that this will be after the session, and it may be there or may not be there. So kindly listen to the lectures very carefully until the time
Okay.
sessions are over.
Okay.
Okay.
Okay, ma'am. The one more last actually, I have completed my master's degree in physics. I'm so very much enthusiastic in quantum mechanics as of now. I don't know how to go forward. Actually, I wish to do a PhD in quantum. I want my my PhD project to be on the applications of quantum mechanics, which is quantum computing as well. as it was discussed today. How can a person who has completed masters in physics can go forward in pursuing a PhD either in India or in abroad?
So in this case, in the current scenario, it has taken many diversions. People are working on quantum sensing, quantum communication, quantum, there are so many other things, algorithms, quantum circuits, and actually making of the quantum computers. So you need to require to have certain skills. Skills can be computational skills, mathematical skills, or there are different other like material science, as I told, and nanotechnology. These are the skills which are required for a particular domain in which you would like to move to. So at this stage, your aim should be to understand and get information and then see the opportunity that how these skills can be translated to any application or any course which will be of helpful to you.
Okay, ma'am. Thank you. Thank you very much.
Yeah. And I would like to say one more thing, that we are beginning with a very basic level. There may be few things which are we are not able to cover within a limited time of say 1 hour or 1 hour 15 minutes. So, but this will give a scope for further learning. The things which are not covered here, you can always go back to your books or to different YouTube videos or other resources. There are MOOC courses also available in order to get acquainted or with the terminology and understand the things, because it is a very limited course and a very basic course. In order to go do advanced things, I think this should become a primer which should lead to more advanced things in near future. Thank you so much. All the best to everyone.
Thank you very much.
Yeah, thank you, ma'am. First of all, let me thank Dr. Jyoti Gushe for this wonderful presentation. Amazing session we had today, the first session. Yes, everyone has to clap.
Thank you.
Yeah, you've made it very clear to us what is superposition, because there are participants are in different age groups. Some of them may find it little difficult, but the way you explained it using animations and those videos, I think they must have really got an idea what. Otherwise, students always get scared of this word quantum, always. So this basics that we have started with definitely will help them. And ma'am, thank you very much for answering all questions very patiently. And we have understood now what we are heading to for the next few days, and we have made a beginning, and the concept of superposition, I'm sure, is understood by everyone in this group. Now, thank you once again, ma'am, for this wonderful session. Thank you. Just a few announcements I'll make. As Vandana ma'am has already said, let me continue to say the same things again. 80% attendance is required for getting a certificate. Also, answer quiz every day. If there are any issues, you can contact the organizers. That also will be recorded for the certificate, for giving the certificates. If there are any doubts, you can always contact the organizers regarding that. Ma'am, are there anything else to be said, Vandana ma'am?
I think over, it's fine. And thank you, Dr. Reshma, for wonderful comparing and taking everything so nicely. Thank you so much.
Yeah.
And thanks to everyone.
Yeah, once again, so we are getting ready for the tomorrow's session now. I'm sure, like me, everyone is very excited now to go to the next session. Thank you again. Thank you, Arvind sir.
Thank you so much.
Yeah. So I'll close the session.
Ma'am. Thank you. Thank you very much.
Thank you. Thank you, sir. Thank you.
Thank you, sir.